You know, in nursing, data is everything, right? It's what drives our decisions, what validates our research. But how do we make sure that data is actually reliable? Well, it all comes down to a core concept called the scales of measurement. So let's dive in.
And this is a question that, honestly, every single one of us grapples with. I mean, think about it. We observe, we chart, we assess constantly. But how do we take all that raw information, a patient's pain report, their blood pressure, their gender, and turn it into actual data we can use for evidence-based care? That's exactly what we're going to break down right now.
Because here's the bottom line, and this is so important. The quality of our data, it directly determines the strength of our conclusions. I mean, if we don't measure things the right way right from the get-go, our research, our evidence, and ultimately our patient care, it can all be compromised. Precision really, really matters.
So to make sure we get that precision, researchers have this system for classifying data. You can think of it like a framework, one that sets the rules for how we assign numbers to what we see. And honestly, it's the foundation we build our entire analysis on.
Okay, so take a look at this. What you're seeing is basically a hierarchy. The best way to think about it is like a ladder. With each step you climb, you get more information and way more statistical power. We're going to start at the bottom with simple categories and work our way up to really precise measurements. And the cool thing is, each level builds on the properties of the one before it.
And hey, to remember these 4 levels, going from the weakest to the most powerful, there's a really easy acronym. NOIR. That's for nominal, ordinal, interval, and ratio. So you ready? Let's start climbing this ladder, starting at the very bottom.
All right, first up is the N in NOIR, and that stands for nominal. This is the most basic, most fundamental level. It's really all about one thing, naming things.
Now, here's the most important thing to get about the nominal scale. The numbers are just labels. That's it. They have absolutely no real mathematical value. So if you code male as 1 and female as 2, it doesn't mean that 2 is somehow more than 1. Nope, it's just a shorthand, a name for that category.
So nominal data has a couple of simple rules. First, the categories can't overlap, right? A patient's blood type is A or B, not both at the same time. Second, every piece of data has to have a home. It has to fit into a category. And, most importantly, there is absolutely no order or ranking. None. And you see this stuff all the time in your daily practice. Every time you document a patient's gender, their medical diagnosis, their blood type. Yep, you're recording nominal data. You're basically just putting information into labeled boxes.
Okay, let's take the next step up the ladder. We're at the O in NOIR now, which is for ordinal. And this is where we finally start to bring some order to our data.
So what ordinal scales do is they take everything from the nominal level, those separate categories, and they add one really important feature, ranking. Now we can say something is higher or lower, better or worse, but, and you gotta remember this, we don't know by how much. That part's a mystery.
So think about it like this. An ordinal scale gives us a clear order, but the spaces between the steps on our ladder, they aren't even. The jump from mild to moderate pain might feel totally different than the jump from moderate to severe pain. The gaps are unknown. And again, this is super common in nursing. Just think about any pain scale you use, or patient satisfaction surveys with those Likert scales, strongly disagree to strongly agree, or even something like levels of education. We all know a master's degree is more than a bachelor's, but you can't say by how many units of education, right? It's just an order.
Okay, we're getting near the top of the ladder now. We're about to hit the 2 most powerful levels of measurement. This is where we stop just ranking things and start actually precisely measuring them. Let's get into interval and ratio.
So, the huge leap forward with the interval scale is that now, the distance between any 2 points is equal. It's consistent. The difference between 20 degrees and 30 degrees is the exact same as the difference between 70 and 80 degrees. But there's a catch. And the catch is that the 0 point is totally arbitrary.
Temperature in Celsius is the perfect example here. When it's 0 degrees Celsius outside, that doesn't mean there's an absence of temperature, right? It's just the specific point where water freezes. And because there's no true 0, you can't do certain math. You can't say that 40 degrees is twice as hot as 20 degrees. The ratio it doesn't work.
And that finally brings us to the very top of the ladder, the ratio scale. This is the whole shebang. It has everything the interval scale has, those equal distances between values, plus the one thing that changes everything, a true absolute zero. When you see a zero on a ratio scale, it means the complete absence of whatever it is you're measuring.
Just think about it. Most of the physiological measurements we take every day, they're ratio data. A heart rate of 0 means, well, no heartbeat. A weight of 0 means no weight. And because we have this true zero, we can finally make those really meaningful comparisons. We can say, with 100% confidence, that one patient weighs exactly twice as much as another.
So yeah, this really nails the one critical thing that separates interval from ratio. It all comes down to that zero. Is it just another point on the scale, like 0 degrees Celsius? Or does it mean nothing, a total absence? That little distinction is exactly what gives the ratio scale all of its power.
All right, so we've made it up the NOIR ladder. We know the 4 levels. But you might be thinking, okay, so what? Why does this actually matter in my day-to-day work? Well, let's get to the payoff, because it matters a lot.
Here it is. This is the big so what. The level of measurement you use literally dictates the kind of math and the kind of statistical tests you're allowed to run. If you use the wrong test for your data, you can end up with completely wrong, totally invalid conclusions. It's that serious.
And this chart here just lays it all out perfectly. Look, with nominal data, all you can really do is count how often something appears. That's it. When you move up to ordinal, okay, now you can find the median. But to do the really powerful stuff like calculating a mean or a standard deviation, you have to be at the interval or ratio level. And to multiply or divide, that's only possible with the ratio scale. See, the higher you climb that ladder, the more statistical tools you get to use.
So if there's one thing you take away from this, let it be this. Whenever you have a choice, whether you're designing a study or just collecting data, always aim for the highest level of measurement you possibly can. For example, measuring someone's actual age in years, that's a ratio scale. It's so much more powerful and flexible than just putting them into an age group like 20 to 30 years old, which is only an ordinal scale.
So the next time you're charting, the next time you enter a number into a patient's file, just pause and think about this. The NOIR framework, it isn't just some abstract concept for researchers. It shapes the very story our data can tell. Understanding these levels lets us collect better information, perform stronger analysis, and ultimately tell a more accurate and powerful story about our patient's health.